we know how to do the derivative of things being multiplied, things being divided, things being added. We know how to do trig functions. We know how to do radicals. We've done a lot of things so far. But if I asked you to do the derivative of, let's say, the square root of 3x squared minus 4, you would write it as a 1/2, but can you actually work that out? We know how to do the derivative if it's x to a power, and if it were a squared, we would FOIL it all out and then do the derivative. But as it's written right now, we don't have a rule to allow us to do that derivative. So that's where the chain rule comes into play. So let's say we had something to the third power. U is not just being a derivative here, it's like some function. So maybe it's a, 2x squared plus 1 to the third or something like that. Okay, if I wanted the derivative, we know if there's 3 of them, we do essentially one at a time, right? You do the derivative of the first, the other 2 stay the same. Derivative of the second, other 2 stay the same. Derivative of the third, other 2 stay the same. So at the end, we have 3 terms. Each of them has a u squared and then a derivative of u in it. Right. So it's like taking this 3, that exponent came down, got the u, you subtract 1 from the power, but then you have this extra piece, that derivative of the inside part. So it's telling us that if we're doing this chain rule, we can use our other rules, but then we have to multiply by the derivative of the inside. So if you have a composition, basically a function inside a function, you do the derivative of the outside part, and the inside stays the same, then we multiply by the derivative of the inside. So the example that I was talking about here, that we couldn't do the derivative. If we tried it, the derivative of the outside, so that's the 1/2 power. So we know the exponent comes down, the inside is staying the same right now. Subtract 1 from the power, so 1/2 minus 1. And then you multiply by the derivative of the inside. What's the derivative of 3x squared minus 4? So then 1/2 times 6x gives us 3x times 6. So we can do the derivative of functions inside other functions now. So that's what we're practicing the rest of the day today. Let's look at this problem. So if I asked you to find this derivative, I definitely don't want to write this out 17 times and multiply it. That would be extremely time consuming. So instead, we can do the chain rule. What's the outside function? The 17th power. So derivative of the outside. So the 17 comes down. The inside doesn't change. Subtract 1 from the power. And then we multiply it with the derivative of the inside. What's the derivative of the inside? So 17 times 6x. Mm-hmm.
Why is Bill 6 pounds?
Sorry, 16. Just making sure you're paying attention. Other questions, sir? You'll notice I asked for like dy dx in this. When you're looking at the chain rule, it says dy dx is dy du times du dx. Don't think of those as fractions. They're representing rates of change. dy du is at saying the derivative of y in terms of u. Du dx is the derivative of u in terms of x. So just understand when you see these, they're meaning a derivative or a rate of change. You're not actually like dividing two numbers. Alright, so if I asked you to do this derivative, what would we probably need to do first? Instead of a square root, we write it as a 1/2 power. So then our derivative, exponent comes down, inside stays the same. Subtract 1 from the power, so 1/2 minus 1. Times derivative of the inside, or we could simplify 1/2 times 2x is just x squared plus 1 to the negative 1/2 power. Let's do one with trig functions. Alright, so if I asked you to do this derivative, what is the outside function? The outside is the sine. So do the derivative of the outside. So the derivative of sine is cosine. Inside stays the same. The inside here meaning my angle. So it's still an x squared. Times. Since it's not just a cosine of x, since the angle is something else, we need to do derivative of the inside. So what is the derivative of x squared? 2x cosine of x. D. And if I do this one, sine x squared means sine squared x means you're taking the sine and squaring that. So what's the outside function this time? The square is on the outside this time. So derivative of the outside. So the square comes down, inside stays the same. Subtract 1 from the power, so it's just to the first. Times derivative of the inside. What is the derivative of sine? So 2 sine x cosine x. Well, it's not times 2, it's to the second power. So we're doing the power rule right now. But when you have an exponent, it comes down to the front. go ahead and go to, I'm going to talk through this one with you, and then I'm going to have you guys try to come through. So this is just kind of understanding, remember, derivatives are rates of change. So an oil refinery makes U liters of gasoline from X barrels of crude oil. Then they make Y grams of petrochemical from the U liters of gasoline. All we're doing here is giving the units for each of these things. Remember, a derivative is a rate of change, so it's just something per something, just like a slope. So it's really just the numerator per the denominator. So dy du. What is y? U is liters, X is barrels, Y is grams. So it would be grams per liter. U is liter. Du dx. So U is liters per X is, so liters per barrel. Last one, dy dx. So y is per X is barrel. So if we have these rates of change, we can use those variables to identify our units. Any questions on that one? I want you guys to try the next few examples on your own. So I'm just going to give you a few minutes, work as far as you can, see how many you can get done, and then we'll start checking them. So 100 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside, which is 3x squared. So you could go ahead and multiply those. So you get 300x squared times x cubed minus 1 to the 99. Get that one? Good. Example 6. Exponent comes down. Inside stays the same. Subtract 1 from the power, so it becomes -4 times. What's the derivative of the inside? You could leave it like this. If you chose to, you could distribute the -3 through that parenthesis. That's kind of optional. If you did that, you get -30x plus 6 times. You guys get that one? Good. Alright, if we look at this one. Exponent comes down. Inside stays the same. Subtract 1 from the power times derivative of the inside. -5. So we get -15 times 2 minus 5x squared. This one, how would you, if it's written like this, what would we have to do? We could, if we don't write it with the negative power, we'd have to do quotient rule, which is going to be fairly ugly. Or we could, probably the easiest option, either one will work. I guess quotient rule probably isn't all that ugly. Or you can write it as this to the -2 power. So totally up to you. Which way did you guys do? The -2, okay. So exponent comes down. Inside stays the same. subtract 1 from the power, derivative of the inside. So you could leave it like that. If you chose, you could take the -2 times this. That's -12x squared plus 2 times 2x cubed minus x plus 7. Okay, that looked like it was where most people got to. Are those going okay? Okay, let's try. See if I can get through. What would I have to do here? Okay. So we start derivative of the outside. What is the outside? The 5th power. So the 5 comes down, inside stays the same. Subtract 1 from the power. Times derivative of the inside. To do the derivative of the inside, we have to do the quotient rule. Low, d high, minus high, d low, over low, squared. Is everybody with me there? I am going to write this as z minus 1 to the 4th over z plus 1 to the 4th. Here we get z plus 1 minus z minus 1 over z plus 1 squared. So if I put these together, what would we do with this negative? Negative z and positive z cancel. 1 plus 1 is 2, so I'm going to go ahead and just multiply that with my 5 and make that a 10. On the bottom, I have z plus 1 to the 4th times z plus 1 squared, so z plus 1 to the 6th. Okay, right here, and I combine my numerator, that's a 2. So then I did 2 times 5 to get 10. A 4. It's just sloppy. So we can get some uglier looking answers on these. I want to stop there for today. There is a handout on Google Classroom. I'm not going to have you do all of them yet because I haven't done. So I want you to skip problems 3 and 4 for now, and we'll probably do them together in class the next time I see you in over a week. But so that gives you 8 problems to do. Most of them are pretty straightforward.